Welcome to my SunGoldPower introduction video. I want to quickly go through my configuration here so you can see how I'm using two of the SunGoldPower inverters in a hybrid environment. I do use other vendor solutions, which is the way it worked out. This is all DIY. It's safe, I'm pretty sure, as far as the electrical work goes and everything else, but I will show you what I'm talking about. So there are two inverters. They're both TP model, see right there, 6048s, which is 6,000 watt inverters, and I've got them hooked up in parallel, just like they mentioned in the documentation. You can have up to 9 of these things all hooked together. And the reason I'm doing this is because I want more AC output. I want to be able to generate more backup power to my house, and I'll show you how all that fits together as well. But let's first look at the actual devices. Here's the battery bank over here. And no, those are not SunGoldPower batteries, so sorry, but they're another vendors. And there's 20 batteries, 12.8 volts, 100 amp hours, all hooked up in, that's 5 cells, making 48 volts each. And they're wired to this panel back here where I've got a 300 amp DC breaker, just so in case I discharge or charge the batteries, that will pop. And then I've got a nice power off switch here, and you can see here I've got some bus bars that are fed by the batteries, red positive, black negative, and then they in turn feed each one of the two TP6048. So there's a battery connection there, and there's another one down here as well. And then as far as the PV panel goes, this is the input from the solar array. I'll show you that in a second. And I've only got that going to one of the TP648s because you can't, and I checked with support, and their support's great, by the way. They respond via email quite quickly. But you can't feed, unlike the DC power coming in and out to the battery array and the AC power coming in and out from the grid. You cannot have your solar panels feed into a bus bar and then from there feed into each one. So I do have the option later on. You see that this is the actual PV connection into the top TP6048 right here, PV input. So that's it's high voltage, low amperage. It's running, up to 450 volts is what these devices can handle. I think they don't start inverting until you get 125 or 150, something like that. That's all in the documentation. Here's the connections between the two TP6048s, just like right out of the manual, and they provided all the cables. It was quite easy. It's a daisy chain configuration for both signal and power, I assume. So you've got the red-black wires with those green connectors down there. You've also got these DB9 serial connections right here. As far as getting it to work, I had bought this particular TP6048 a year ago, and then I bought the second one just a few months ago, and they had different firmware, so I had to go and get the firmware to match, because there are error codes that are mentioned in the manual. When you do hook them up together, power them up, they'll issue codes. One of the codes indicates that the software isn't the same. Unfortunately, I was not able to use the latest firmware off the SunGoldPower's download website. There's a download section in their website. I had to actually contact support, which is a little annoying. I would rather have just done it myself. But again, they were very fast to respond. And they gave me the file. They just use a website where you can download the latest firmware, the correct firmware for both these devices. And that was a fairly straightforward process of upgrading the firmware. Nothing super scary there. Although it is scary when you do it and you're afraid you might brick your device. But it all worked fine. And it was really nice. You can actually see on this display right here where it says HS. That means, I believe, this one is the master node right now, and then this one down here is flashing SL, meaning it's the slave node. So these devices will automatically vote, I guess, each other. And you can see also here I've got it's a nice bright sunny chilly day here in North Florida, but I've got some solar energy coming in. I've got the batteries are being charged, and there's also a load, AC load. So I've got both inverters going. As far as the AC connections coming out, you see these orange wires here go into my panel. This is not the prettiest thing in the world, but it's work. It's all grounded. And this panel right here, it's a hot mess, I know. It's just a little panel. It's got a couple of 15 amp and some 30 amp, a 30 amp breaker and a 20 amp breaker. The 20 amp feeds my well pump, because that was one of the whole reasons for having this is in a hurricane I want to be able to have water to the house, even if there's no grid power at all. And eventually I want to grow this capacity to handle the whole house load. It can't quite right now. And I'm probably going to need a couple more of these all hooked together in parallel like these are, because each one of these I think adds 20 to 30 amps of 240 to this feed right here. So again, these two TP6048s are feeding their AC inverter output into this little square D panel right here. And then I've got it doing some interesting things. One of them is just a hobby, is doing cryptocurrency mining, which is totally a waste of time and energy. I'll probably stop it again because it's not very lucrative, but it's a convenient place to do it and have it be have it be solar powered mostly rather than grid powered. Also, I take advantage of the serial port. You see here's a serial cable connected into both the devices. At first I thought that they would need their own serial port, and I'll show you the software later. They have this Solar Power Java app. It's a binary that you have. Again, slight complaint to SunGoldPower. They don't give the latest version on their website in the downloads. I wish they would. You have to contact support, and I've had issues getting a non-corrupted zip file, but that's another story. Anyway, so I've got the program. I'll show it to you later. It will show you better details than by simply going through these displays, which I'm sure you guys have all done before if you have one of these things. I will also show you that the serial connection here is going into this USB port on this this is actually it's a mining rig, just a motherboard that will let you put in multiple video cards. It's a cheap little thing, 200 bucks. And in that, I'm actually not only running this not very lucrative mining stuff, but I'm also running the software from it. I also use the app that comes, the solar panel app that comes from SunGoldPower on my phone, and I'll show you some screenshots of that as well. Here's a quick shot of the solar panel array. It's configured, there's 24 panels out there, I believe, 3x8, and they're configured in 2 strings of 12 solar panels a piece, and that was the right measurement, because I created the strings to get the voltage as high as possible during the brightest time of the day and the year without exceeding that 450 volts, which will cause the inverters to actually trip off, because I'm trying to maximize voltage and minimize amperage so that these wires that come between, that carry the solar energy don't have to be super thick. I also want to demonstrate down here. This is it's a 30 amp 240 volt connection from the grid, and I've got to select into this little switch here, and I've got a selector where I can feed these two TP6048s with AC power either from the grid. You can see there's a hand drawn, that's my wife's handwriting. It says grid or none or generator. Then I've also got a 50 amp monster cable here that will actually connect to a generator, a gas generator right there. You can see a big old 50 amp connector right there. So I can run this thing. You have settings you can put inside the inverters that control the priority of where your energy goes. And right now I've got it set so that it's going to prefer to charge the batteries from the solar, of course, because it's free, or prepaid, if you will. And then when it's too dark or not enough energy is coming out of the solar array, then it will use this source to charge the batteries as well. And I've got the battery charging. Here's an ammeter connected into the battery line, the actual battery, so I can keep it track. And this is kept track of too in the software, of course, from SunGoldPower. But there's 15 amps, 16 amps of 48 volt, 50 voltish power going, because this is a 48 volt system, right? So it's throwing 50 something volts of energy at these batteries over here. I also have battery equalizers for each 4 batteries. Again, these are 12 volt batteries connected in series, and then I've got 5 of them connected in parallel to get that, the 48 volt array. And I find the battery equalizers really help. If you don't use these, you might have a cell that will be charging faster or slower than the other ones. And this way it tends to make the batteries last longer. So you see I've got one with every pack of 4 batteries right there, which is very useful. Just a side topic, I like to monitor the power. Again, this is a different vendor, but it's a cute little, pretty inexpensive, less than $100 US. It's a ammeter, right? One of these devices you hook into your panel, your AC panel, either in your house, in this case it works great for this. And then I've got individual ammeters connected to each of the circuits. That's why it looks like such a hot mess. So I can actually monitor the power coming out of the array of the inverters, and then also how it's being fed into each one of the circuits. And there's an app for that that I can show you as well. Here's my well pump, and you can't quite see the routing, but this is another one of those AC switches. And the current position it's in is set to use the power coming from the solar system, from the solar array, which is right over there in that little plastic shed. So my well pump is always powered by solar first, and again, depending on how the inverters are configured, if the solar doesn't have enough energy or there's not enough battery energy, it will use the grid. I can also put it into a neutral position where it's not connected to anything, which is great for maintenance, or I can connect it up or have it go directly from the grid as well. So I can, if I want to do maintenance on the solar system, then I can still have water in the house. Just to complete the story, this is the house panel, fed from the grid, of course, and this is a very inexpensive transfer switch. It's really just a mechanical device that prevents me from powering up the house from both the grid, which of course is the big switch there, that 200 amp switch. And then what I've done is I piggyback, just like you would do if you had a generator wired into your panel. Those two, you can see right here, those two, that breaker right there, that 30 amp breaker that has warning on it. This device here will actually only let you turn on this switch when that one's off, and vice versa. That way you can't have two sources of AC power fighting for your house. What that means though is that I can take the solar power, which this other panel here, this is the feed from the solar, right? It comes from that shed you just saw. And with 2 inverters, I can get, I guess, normally 50, 60 amps worth of 240, which of course, single phase can be split into 120 or 240, depending on what I'm wanting to do. So I can feed this whole panel here. If I turn this off and then I slide this thing up and then I turn this on, it will energize this whole panel, the house, from the solar. There are breakers on this side. There's a breaker here, 100 amp breaker. There's a 30 amp on the other side too. So I want to make sure I don't, cause any wires to heat up and start a fire. So there is a limit on the amount of energy I can push from the solar system to the house. But it's enough right now to be able to power the hot water heater and the well pump. So I can have hot water. And of course the small stuff, like the low amperage things like refrigerators and lights and that sort of thing, are easily powered by the solar array as well. And I've even got, this is actually just another example of these where I can temporarily, it's a kind of it's weird wiring, but I've actually wired some of the circuits here, some of the smaller circuits for the pool pump. That's what this is for. Then for 2 of the house or 2 of the offices, to where I can either have it running, like right now, that's running off the grid. If I do that, now it's running off of, I gotta fix the wire there. Now it's running off of the solar. Same with over here. So I can quickly, during a normal day when I'm trying to save money on my grid power, I can
could you say that again?
I can run some of the house on solar, some of the circuits on solar. All right, continuing, I want to show you some of the monitoring that's possible with these devices. This is the mobile app on my iPhone, my iOS device. These are screenshots because I'm actually using the phone to record this. So sorry for the shaky camera. Anyway, this shows the actual 2 TP6048s. You can see there's their serial numbers, what have you. And for whatever reason, my older one tends to go offline with the Wi-Fi module a certain time of day. I haven't bothered to bug them, but the other one works fine. And they both work fine. They keep doing their jobs. They're charging batteries, discharging batteries. They're controlling the AC. You know, they're doing their MPPT stuff, which is great. It's just now and then I'll lose some monitoring only through this app. Here's a screenshot. I love this one too. This shows you the current generation of solar power. You can see, you know, I'm probably going to get close to, there's the time reading in the bottom, and then there's the total power that's generated at that particular point in time. So this is about noontime as I'm recording this, and that'll make a classic curve depending on how sunny of a day it is, which is still, it's quite sunny. It's anywhere, you'll see on the other software, anywhere from, you know, a max of around 12 kilowatt hours of power generated from my array. So those are not great panels. They're 195 watt panels. Probably not the most efficient because they're a little older, but I will, I'm trying to do things, you know, DIY and on a budget here. So buying used panels that are past their prime still gives you some generation. I'm paying $20 for a panel versus $200 for something that used to generate 250 watts is certainly still somewhat viable. But anyway, that's waxing there a little bit. Here's a screenshot of when you drill into one of the TP 6048s. You've seen probably, if you run the software, you know what I'm talking about. There's this animation up here will actually, the little yellow dots will indicate which way it flows. So right now it happens to be in battery mode at the time I took this screenshot. So it's actually running my power, you know, the power that's connected from the inverter side out to parts of my house, and also to that mining rig, which tends to be a pretty big power hog as well. Then this is a screenshot. I can show you this better if we look at a different website. This is a screenshot of the other software from the Emporia device. Again, I know I'm mixing my vendors here, but I figured I'd give you guys the full lowdown of all the different things that I'm using here because it's interesting. And this looks like this. I'll just show you real quickly here. So I'm looking at, this is the, oops, sorry for the glare. This is not that great, but let me just go back here. This shows you right now I'm pulling, it's a nice app though. It shows you I'm pulling, this is real time because it's actually monitoring in seconds, and I can go back and look at minutes and hours and days. You know, I kind of wish SunGoldPower had the same sort of, because I'm sure they're storing this up in the cloud, this company is. I wish we had the same sort of flexibility. I can download the data though, so in their defense, they do allow you to download all the data using that Java-based app that I'll show you in a minute. But so right now, I'm only drawing 600 watts of AC power off of the from the inverters, which is not that bad. And then over here, I've got, I remember how to get there. I think I click right here, right there. Still figuring out this software, so my apologies. But now I can drill into each one of those different circuits. I've got 8 different ammeters. That was that white mess inside of that small panel that allows me to look to see how all these different devices are running, which is fun. Okay, this is the Solar Power app written by SunGoldPower. Again, they tried to send me a newer version, but I've had not much fun just because I'm unable to get a decent zip file that's not corrupted. So I'll keep banging on that, but it works fine. It's not a big deal. I just like having the latest software. I figure there's fewer bugs, sometimes newer bugs, but sometimes fewer. So you can see here, if I show you here, this is coming off that serial cable that you saw, and I've got 2 serial cables, but I found I only need 1 connected because they are in parallel. So the data that's streaming over that serial port connected to my motherboard sees the data from both inverters. You can see right here, here's the actual, you know, the COM4 is the actual serial port on the Windows box that's reading this, and then each one of these represent each of the 2 TP6480s, right? Which is kind of cool. And then as far as the configuration goes, I want to show you, if you look at the actual device information, you know, I've got them set up to be off grid. This is the version of the software that I had to upgrade the firmware in both of them so that they were able to connect in parallel. Before I did that, I was not able to get them to see each other, which makes sense. I mean, that's, as a software engineer, I totally get the way that has to work. So you can see you've got the main processor version right there, and then over here you've got the CPU version of the slave. So that matches between these two devices. If I click there, and then I click back over here, and then I go to view, and I go to monitor device information, it gives me the same version numbers right there. It was a little scary because, you know, like any firmware, the term in the industry is brick. You don't want to brick your device where it's unusable. And then you have to go and and beg with your vendor to replace it or anything else. As far as actual software goes, it's quite nice. This again, this is a little graphic here. This is a live animation that shows you what mode it's in. It's in battery mode right now, right? So it's decided there's enough energy in the battery array to run the load off the battery and the solar, which is great. So I've got, you know, energy coming in from the solar array into the inverter, and you can see from this animation here that where the flow is from the battery into the inverter here, and then the load represented by that little old school looks like a CFL, compact fluorescent light. And then over here are stats about the volt. This is the voltage, and this is kind of interesting because remember, I've only got the solar array connected to one of the two. So the one I've clicked right now over here is the one that doesn't have the solar power coming to it. So you can see there's a little voltage there, but there's no power. If I click on the other one and then come back over here, now you can see I've got 186 volts. Again, that's 12 panels, 195 watts hooked in series, and there's two of those that go to a combiner box. So they're combined, they're generating right now 2,700 watts, 2.7 kilowatts of power, which is, again, not bad. That's where I get to my 10 or 12 a day. And there's my grid voltage. It's coming in. You know, I've got it. It's the L1, L2 off the line. So I've got 240 nominal volts there that can then be used by the device however it deems appropriate. There's my frequencies and whatnot. Over here you have, I wish this was a little better displayed, but you've got here, hang on, let me grow this window a little bit. Come on. Oh, by the way, I'm using Google Chrome Remote Desktop, and actually it's basically like an RDP for those IT people out there, so I can access this software anywhere, even from my phone or whatnot, because, you know, it's a modern world with nice modern tools. Because this is a Java-based application here. You know, it's you can see it's got the original Sun 2005 Sun Microsystems, which is no longer, you know, that company doesn't exist anymore, but it's just kind of fun. Anyway, it's a nice app. I just would like to get a newer version. So SunGoldPower, if you're listening, please put it on your website for all of us to enjoy. But here we have, I'll just scroll through it this way. We've got it shows you AC output power for L1, for L2, for each leg of the 240, and it's actually split between the devices, right? Because that's the whole point of this, of having more than one of these. And if I had 3 or 4, I'm sure it would take the load, which is pretty neat. It takes the load, the AC load, and splits it across the inverter so that you don't exceed the amperage, the max output of any one inverter. So it load balances, which is quite nice. You can see here is my battery voltage right now, you know, right? And if you've done 48 volt stuff, you know that's pretty good. That's close to 100%. And it's actually charging as well right now. So there's enough energy to not only throw 40 amps of 50 something volts into the battery array, those 20 batteries, 100 amp hour batteries, but there's also enough to you have both inverters send some AC power. You can see there's 165 watts coming off that leg, and then down here it gives you the apparent power and the active power as well. So that's why I like having a separate independent AC monitoring outside of the system, so I can get a better view. I mean, this is a great view, don't get me wrong, of how the inverters are splitting up the work, but I'd also like to see how it's actually being used by the devices outside. And it gives me data over time. Now you do get some data over time here at the bottom. Like this is there's a per hour, which, you know, sorry, SunGoldPower, this has never worked. I've never seen any data when I click on per hour over here. I've never seen any data here at all, which is unfortunate. It doesn't matter which inverter I'm looking at, but daily does seem to, and I'm thinking this is stored in the device itself. So You can see here I've gotten the last couple of days here 11 kilowatt hours, 9, 12. This was a cloudy day, that kind of thing. So not great, not a lot of generation. I need more panels for sure. Well, I'll get there eventually over time. And then monthly, that's just over the whole month, how much power's been generated, and then annually there's that as well. Remember, I switched my solar, so this is showing the data just from that one device. If I click into the older device here and click on monthly, well, I guess it's not. I think you have to double click. It has to actually change the name. It's actually got the name of it. This is a little clunky, but this is the one that's currently showing you. And over here is where you pick that. So I got to double click until there. Now it changed over here. And then now when I go down here and look at my stats, it should change as well. This isn't a big deal. It's just a nuance of the way. So I think this data is only coming off of one of the two inverters. Not a big deal though. Anyway, that's it in a nutshell. That's the system, what currently looks like. Again, my future plans are to keep an eye on the total AC output. I don't have enough to really, increase everything. Increase the batteries, increase the number of inverters, increase the number of solar panels. I've also, I'm not going to show it to you now, but the backyard is arranged in a way where I could have panels pointing different directions depending on the time of day to be able to pick up different amounts of energy. Because right now you can see from that graph that I showed you before, there's a peak around noonish or 1 o'clock a local time of when there's the most generation, and it drops off fairly quick. Anyway, I hope you enjoyed this. I hope you enjoy your SunGoldPower. They've been a pretty good company to work with. I've already talked about some nitpicks, nitnoids, and let's hope that they keep supporting these products, because I do worry these are older. They're not the latest and greatest ones that they're marketing necessarily heavily, but they're still available and they still have good support for making sure that people like myself that are maybe don't want to buy the latest and greatest, but the little bit cheaper ones, and be able to still use them and burn new firmware and actually get support. So good luck with any of your solar DIY projects. Bye-bye.